Hello. Okay, this video describes about molecular geometries and bonding theories. In chapter 9, there are mainly uh, things that we learn is we talk about geometry of the molecule, and then we talk about valence bond theory, and also we talk about molecular orbital theory. So mainly if you know how to predict the geometries, and then valence bond theory and molecular orbital theory. And also we talk about polarity of the bonds and magnetism. So let's first look at the geometries. There are two types of geometries. If I draw, um, they have molecular geometry. Sorry, molecular geometry, electron geometry. Okay. So, what is the difference in geometry? Always this electron or molecular geometry help you to predict the 3D orientation of the molecule. Electron geometry, you look at the number of electron domains around the central atom and then you predict the geometry. Molecular geometry, you look at the electron domains around the central atom, but you differentiate them as bonding electron groups and non-bonding electron groups. So let's look at these things in detail. So thinking about the molecular shapes, there are five main shapes: linear, trigonal planar shapes, linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral. So basically, two electron groups around the central atom, linear, two electron groups. Three electron groups around the central atom, trigonal planar. Tetrahedral, four electron groups. Trigonal bipyramidal, five electron groups. Octahedral, six electron groups around the central atom. Let's take first geometry, which is linear. Linear electron geometry. Linear electron geometry. Whenever you have two electron groups around the central atom, it is electron geometry is linear, bond angle 180 degrees. Example, if you see in this diagram, the next slide. So this is linear. If you see this one, it is the linear. If you see, this is the central atom. Two electron groups around the central atom. It is linear. In the linear, bond angle is 180. Example of the molecule beryllium fluoride. If I draw beryllium fluoride, this is linear. And you clearly see the bond angle is 180 degrees. This is the bond angle, 180 degrees. Okay. And let's see what is the difference between electron geometry and molecular geometry. Electron geometry, you need to look at the electron domains around the central atom. You don't differentiate them as lone pairs or bonding pairs. Example, let's take an example, ammonia. In H3, if I draw Lewis structure, This is NH3. So now tell me how many electron domains around the central atom. If I see 1, 2, 3, 4 electron domains around the central atom. In these 4 electron domains, electron geometry, 4 electron groups around the central atom, that is tetrahedral. This is electron geometry. What about molecular geometry? Molecular geometry, you have 3 bonding groups, 1 lone pair. 3 bonding groups, 1 lone pair. That means you have 4 electron groups around the central atom. From 4 electron groups, 3 bonding, 1 lone pair, it becomes um, trigonal pyramidal. Let's take another example to see the difference between electron geometry and molecular geometry. Let me take water as an example. H2O, you need to draw Lewis structure. O is the center atom. Hydrogen, hydrogen. I have two lone pairs. So, how many electron domains? 1, 2, 3, 4. 4 electron domains around the central atom. That means electron geometry. In electron geometry, you just count number of electron domains around the central atom. So, electron geometry is tetrahedral. What is the molecular geometry? Molecular geometry, 4 electron groups around the central atom, 2 bonding, 2 lone pairs. It's going to be bent. So now I think you have clear understanding what is the electron geometry and molecular geometry. Always keep in mind, electron geometry, you count number of electron domains. Think about this kind of example, CO3 2 minus. CO3 2 minus, CO3 2 minus, how many electron domains? This double bond also considered as a 1 electron domain. So 3 electron domains around the central atom. That's very important. You need to know how to draw clear correct Lewis structure and also identify the clear electron domains. So now let's look at again each and every um, uh, geometries. We did linear, 2 electron groups around the central atom. It is linear. Now let's look at the 3 electron groups around the central atom. 3 electron groups around the central atom. It is trigonal, planar, trigonal planar electron geometry. Example, BF3. BF3 is a good example. Boron, F, F, F. So this is, let me do the complete octet. Okay, so this is trigonal planar, 3 electron groups around the central atom. 1, 2, 3. 3 electron groups around the central atom, trigonal planar. So what if we have 3 electron groups around the central atom and 1 lone pair? 3 electron groups around the central atom, 1 lone pair gives bent geometry. Let me give you an example. Example NO2 minus. NO2 minus is a bent. So 3 electron groups around the central atom, all bonding pairs, it's trigonal planar. If you don't have lone pairs, number of electron geometry and molecular geometry is same. But if you take this structure in O2 minus, if you draw the structure, nitrogen is the center atom. You have oxygen, 1, 2, 3, 4. Oxygen, 1, 2, 3, 4, 5, 6. and NO2 minus. So you have three electron groups, right? Domains 1, 2, 3. That's minus here. So three electron groups around the central atom, two bonding, one lone pair gives bent molecular geometry. But still, electron geometry is trigonoplanar. Then we'll move to the tetrahedral geometry. Tetrahedral, four electron groups around the central atom. Tetrahedral geometry, four electron groups around the central atom, all bonding, molecular geometry, electron geometry, tetrahedral. Example CH4. Four electron groups around the central atom. This, if I ask you what is the electron geometry, tetrahedral. What is the molecular geometry? Again, tetrahedral. If you don't have lone pairs, it's always electron geometry and molecular geometry become similar one. So electron geometry and molecular geometry same. Only situation where the electron geometry and molecular geometry differ when you have the lone pairs in the structure. Tetrahedral. Tetrahedral bond angle 109.5. And then you go to the four electron groups around the central atom, one lone pair. At that time, example ammonia, N, H, H, H. You have the lone pair. This is, I write EG for electron geometry. Electron geometry, four electron groups around the central atom, 1, 2, 3, 4. Electron geometry still tetrahedral. What is the molecular geometry? Molecular geometry, four electron groups around the central atom, one lone pair, three bonding groups. It's going to be trigonal pyramid. Now, another structure, water, O, H, H. Four electron groups, right? So, electron geometry, tetrahedral. Molecular geometry, bent. So now, these are all the structures that have 8 electrons around the valence shell. And now we are looking at hypervalent structures. Hypervalent means molecules accommodate more than 8 electrons in their valence in the period 3 and accommodate more than phosphorus. Some examples that can have hypervalent molecules. So if you look at the next electron geometry, which is trigonal bipyramidal. So this is trigonal bipyramidal. Five electron groups or domains. Okay, five electron domains. So if I show you three electron groups in one plane, let me show you the PowerPoint. If you see, so these three electron groups in one plane, 1, 2, 3, up and down. So the three electron groups in one plane we call equatorial bonds, up and down axial positions. So this is the five electron group position, trigonal bipyramidal. It's like two pyramids on the top of each other, electron groups around the central atom, all bonding trigonal bipyramidal. Always, if lone pair comes, they come to equatorial positions. So if one lone pair, it is seesaw. If you have two lone pairs, it is T-shaped. Three lone pairs, it is linear. Okay, and then uh, so in the 5 electron groups, all bonding is trigonal bipyramidal. 5 electron groups. Show you with the PowerPoint. 5 electron groups with the let me explain this. 5 electron groups with no lone pairs or trigonal bipyramidal. 5 electron groups, 4 bonding, 1 lone pair, seesaw. 5 electron groups, 3 bonding, 2 lone pairs, T-shaped. 5 electron groups, 2 bonding, 3 lone pairs, that is linear. This is the 5 electron group structure, and then we are going to octahedral. Octahedral is 6 electron groups around the central atom. So in the octahedral, 6 electron groups around the central atom, no lone pairs, all bonding, octahedral molecular geometry, and also electron geometry also octahedral. Always keep in mind, if you have 6 electron groups, no matter what, they are bonding pairs or non-bonding pairs. It's octahedral electron geometry. The only thing changes is molecular geometry depending on the number of lone pairs. And then you have one lone pair, square pyramidal, four bonding, two lone pairs, square planar. So this is the electron and molecular geometry of molecules. To summarize, I'd like to show you this table. We talk about linear electron geometry, 2 electron groups around the central atom, 3 electron groups around the central atom, it's trigonal planar electron geometry, no lone pairs, it's molecular geometry also trigonal plane. If you have one lone pair, it's going to be bent. 4 electron groups around the central atom, always electron geometry is tetrahedral. If you have one lone pair, trigonal pyramidal, 2 lone pairs is bent. 5 electron groups, always electron geometry is trigonal bipyramidal. Depending on the number of lone pairs, you'll get seesaw if it is a one lone pair, T-shape, 2 lone pairs, linear, 3 lone pairs. 6 electron groups around the central atom octahedral, 1 lone pair square pyramidal, 2 lone pairs square planar. With that, I hope you understand, and if you have any questions, you can always email me or you can contact me in the class.